And this is Mayank.
And we're here to talk about a project Lextor.
So Lextor is basically a connected platform where robots come together, share their data in order to achieve the sustainable development goals set by the United Nations.
So why did we come up with this project? We're all facing several issues.
Like the traffic, 16 people die every hour. 40,000 liters of petrol is wasted due to traffic jam. And out of every 5 minutes of traffic jam, 2 minutes are caused due to accident.
Energy is also a major concern as 20% of the population still doesn't have access to electricity.
And then there is the threat to marine and aquatic life. 40% of ocean is threatened due to human activity.
So, in order to tackle all the situations, the United Nations came up with a set of 17 Sustainable Development Goals,
which you can see above. So Lextor is basically going to use robots in order to help humans achieve their sustainable development goals.
So robots are not the future big trend, but the now big trend.
What we are planning to do is use an artificial intelligence in order to control all these robots, because humans cannot always be there in order to supervise on everything. So artificial intelligence is going to monitor these robots.
So what exactly is Lextor? In simpler terms, Lextor is nothing but a system where robots talk. And for this purpose, we create 3 categories of robots. The wheel robots, which will work on land, the drones, which will work in the air, and the aqua robots, which are going to work in water.
3 things that you should know about Lextor is that its design, its working, and the services that we are going to provide.
Talking about the design, our design is inspired from nature. Like the bees are also creating a swarm of robots in all 3 domains.
We are also going to incorporate our artificial neural network, which is going to replicate the function of a human brain.
The robots will be working on the principle of division of labor, just like the bees. So we'll be having a queen robot commanding its worker robots.
So the robots take in the input from different sensors that we place on them. These things are then processed in Raspberry Pi, and the specific file of each sensor gets saved. Then these things are sent to Azure where different algorithms try to analyze the data, and after which the analyzed data is sent back again to the Raspberry Pi, after which these outputs are worked upon by the robot.
So we'll be targeting 7 of the 17 United Nations Sustainable Development Goals, which are health, energy, decent work conditions, industry, innovation and infrastructure, climate, life below water, and life on land.
So this technically means that our services can be available by different sectors and different regions, and everything about our services can be seen in the region.
So what makes Lextor so unique is the fact that one platform is going to provide multiple possibilities.
Hey guys, so this is a demo of Lextor, and here I am going to try to measure the distance using an ultrasonic sensor and send it to cloud and then retrieve the data and show it on the web. So first I'm going to SSH into our Raspberry Pi. We are going to transfer these files onto the desktop of Raspberry Pi. We have our files for here, and now I'm going to run ultrasonic. So as you can see, it is printing the command that is currently being executed, and the command that is currently being executed is stop. We have 2 commands, start and a stop command. So here what we are going to do is enabling start. Now as you can see, the ultrasonic sensor has started running. It has logged into the Microsoft STP servers, and it has successfully uploaded the sensor data. Now let's stop the scan again. So now it is running the stop data again. What actually happens is that we have a text file on a web server, and here the command which we want to execute is that. Now let us check if the Raspberry Pi displays. If I run the FTP from idle, the upload is successful, and what we get is the data being displayed here. Now if you can't see anything, then sorry. Yes, as you can see, the output is displayed here now. So and the distance that I measured is 50 centimeters. Okay, so from here to wherever the signal is bouncing, it is 50 centimeters.